Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're gonna talk about 802.11ah or Wi-Fi HaLOW. So let's dive deep into it. Now, what exactly is the idea here? Well, idea is that Wi-Fi is great as LAN, as in local area network, meaning if you want to create a network, most likely you're going to use Wi-Fi. Your mobile has Wi-Fi, your TV has more Wi-Fi, your kitchen bell has Wi-Fi, and your doorbell has Wi-Fi. Every Tom, Dick, and Harry has Wi-Fi. So Wi-Fi is very good, very awesome, no discussion about it. However, the range is tiny, meaning if you are actually using, let's say 5 gigahertz, the range is measured in meters. If you are using 2.5 gigahertz, okay, you can touch 50-60 meters. So reality is range-wise. As a wireless technology, range-wise, this puppy sucks. So in this new era of the world that we are inhabiting right now, the world of IoT, Internet of Things devices, is growing exponentially, meaning we're gonna have more devices on the quote-unquote internet than we're gonna have humans on the internet. So that number is growing exponentially. Then you have long-range security devices, meaning let's say you have a property, you want to have cameras monitoring all other things, but again, laying down a fiber or Ethernet that is like hundreds of meter long, yeah, that's not viable. By the way, you can only do with fiber. Good luck trying to do that with Ethernet. If I'm not mistaken, single run of Ethernet should not cross around, let's say, 100 meters or something. You're gonna need a booster for it. So that's a serious issue. If you need long-range security, that requires some amount of bandwidth. It's very difficult to do. And you also need low power, meaning these things many times could be running on solar power, it could be running on batteries, it could be running on some like very limited power budget. In those scenarios, you cannot be like, oh, the radio itself consumes majority of the power. That would be painful. So the power requirement is also a critical thing. Now, system must be built, like again, you take the Wi-Fi, but you rebuild it, like you redesign the core construction for range and low power. Now you're like, wait a minute, you are telling me that we can increase the range and we can reduce the power consumption. Doesn't that sound magic? Well, yes, if it had the same speed. That's the compromise of here. Like it's the same. Like a transformer can increase the voltage, but it will decrease the amperage. Same goes here. Like you can get the range, you can get the low power, but you have to sacrifice bandwidth, meaning how much oomph you can transfer. Basically, instead of megabytes per second, hundreds of megabytes per second, 1 gigabyte per second, that puppy will go down to megabits per second. So you have to understand, like fundamentally, there is a price to be paid. And how you're gonna achieve that on a physical level? In physical level, you're gonna use lower frequency for range, and you can experience this right now. If you have a Wi-Fi router, you must have noticed that 5 gigahertz, while it does give you awesome speed, it does not give you awesome range. That's why we still have 2.5 gigahertz. And same goes here. What if you go even lower in frequency? You can go even further. Now you may be tempted to ask, what if I go really low frequency? Can I talk around the planet? Yes, some wavelengths do bounce off at the higher atmospheres. So you do have the luxury of talking around the planet using a very low power radio. And yes, we used to do that. Why don't we do that right now? Yeah, it's very low bandwidth and it gets affected by atmosphere a lot. And the antennas have to be huge, not huge, huge. It has to be huge. But does work. The principle does work. So lower the frequency, higher the range. So in this new world where we have a plant that has a screen that is showing you the water level, in this sort of world that we are in, a practical world of like robotics where you do want to put a sensor array on every single motor so you can make them last longer and you can figure things out before it goes bad. Basically, bearings generally do not fail. Bye-bye. They always have like, okay, starting to grind, something is bad happening, then it's starting to vibrate. If you can replace it at that point, motor will be salvageable. But if you waited, or like, you have a very dumb system where it's like, it only stops when motor is drawing way too much power, then you're like, yeah, you missed the zone where you could have repaired it. So industry is working their ass off to put as much sensor as possible on equipments. So you can understand IoT for industrial work is a different thing. Like for home, that's I'm a bit uncomfortable with that. For industry, it's compulsory. So let's dive a loop into Wi-Fi HaLOW. So Wi-Fi HaLOW is a protocol that was established in 2017. Now be very mindful whenever we say established or protocols or things of that nature, it's always done by the core authority, like who designs USB-C or who designs USB 5 Gbps, USB 10 Gbps, USB 20 Gbps. They have a central body known as USB Association. Same with Wi-Fi Alliance. So we generally always have a central association who's responsible for ratifying everything. Otherwise, every company will create their own custom Hululu and will be in miserable situation. Look into Android's power charger. That's why European Union fired a law that's like, brah, all of you throw all your proprietary stuff away and use power delivery. Same here. So Wi-Fi HaLOW was a foundation of which was laid down in 2017. So whenever the foundation is laid out, it takes few years to like finalize the thing. Then it takes few years more after that to have like actual hardware, and then hardware reaching the consumer audience. So do not be alarmed by like 2017, that's so old. It's like, yeah, it's normal. It's normal. So for example, right now there is a standard for Wi-Fi that is 60 gigahertz. Like, wait a minute, is that true? Well, yeah, it's old system known as Y-Gig. It was designed specifically for virtual environment. Basically, if you need a remote connection for some reason, you need wireless and you need to transmit bonkers amount of data. Basically, your some sort of media player to your TV, and you want to send uncompressed data stream, and like, you know, your same thing from your graphics card to your VR headset. Those sort of ecosystem would benefit from that. Not that much of a use. 6 gigahertz, again, that also has the issue of like legal boundaries, as in like not every country is comfortable with that. So same thing goes here. So new boundary was established, that was go below 1 gigahertz, or what we call sub gigahertz band, as in 900 megahertz is the sweet spot they have chosen. Now be very mindful, every nation has a different allotment of that, meaning the radio, the hardware that you will buy should work in every country, but it will shift its radio frequency once it detects which nation it is. So for example, in USA you should get 902 megahertz to 928 megahertz. If you are in Korea, you should get 917 megahertz to 923 megahertz. Europe 863 megahertz to 868 megahertz. In China it goes very low, as in like 755 megahertz to 787. Japan 916 to 927. Singapore, that I'm really sure Singapore has something in between, so they have 866 to 869 and 920 to 925. I'm pretty sure there is something exactly here that government is using for either weather satellites or something they must be using, and it should be high priority enough where they're like, yeah, let's just lock it right there. So you can see how much is the total bandwidth is different. Like USA gets 16 and like China gets 8, but if you are in Europe you only get 2 megahertz, and Singapore does get 4, and if you are in Japan only 1 megahertz. So you get the point. And that's the same thing with Wi-Fi 7. Not every country will get same Wi-Fi 7 experience. Some places will get wide of basically USA will get really wide bandwidth, Europe will get half, and other nations will get very tiny or flat out block 6 gigahertz. So depending on your nation, you may get awesome experience or no experience. In thankfully Wi-Fi HaLOW case, it will work in almost all countries. It's just basically the handshake is a bit different, where it's like, okay, I'm in USA, I'm gonna handshake in that band. I'm in basically Singapore, I'm gonna handshake in different band. That's it. So that's the frequency part. What about the core protocol of it? Now this is one thing after, whenever you're talking about radios, it's not just radio, done, go home. You do not send data signal to the wave. There has to be encoding, decoding, modulation, all of that. Like, there is a lot of handshake, there are a lot of encryption, decryption, keys, all that jazz. So what they did is very clever. They directly control C, control V Wi-Fi 5. They took Wi-Fi 5 2017 and they just swapped the radio part. In terms of change, they have only changed one core element. The core element is because they understood that Internet of Things device and people want to plonk bonkers amount of it. The core algorithm is designed such a way that it can scale up to 8,000 devices to one network. Like, it's inherently designed, like the numbering system is designed such a way that it can handle and address that many devices. I have only seen 1500 devices in one go and 1000 in real world deployment, nothing more than that, but you get the point. Like, that's the part they changed, but everything else is Wi-Fi 5. So think of it this way, like you took a Wi-Fi 5's everything and just put the hardware on a basically down converter. Those of you who work with software defined radio know what that is. It's basically you can shift the frequency. You can take a very high frequency and bring it down, or take very low frequency, bring it up. So they down converted that puppy. Now speed will drop. That's the penalty that you have to pay. Now why speed is low? Well, speed is low because you have choice to make. For example, the fattest bandwidth that you have, it's 16 megahertz, but you may be like, hey, first, that's only available in one country, or in India. But 8 megahertz, that's you can get that in a few places. 4 megahertz, most places you should get 4 megahertz, and then you have 2 megahertz and 1 megahertz. Now these are slots available. Now your Wi-Fi router also does the same thing, same your channel routes and all that. So in 2.5 gigahertz, the smallest channel is 20 megahertz wide. So you can see fundamentally the track width, basically how many lanes of highway you have, it's fundamentally smaller. And then you realistically will get even smaller. Now, benefit of getting smaller and smaller, you get higher range. More data packets can be sent much further because it's very small packet, and on top of that, you can send resending it, as in like, dropped packet would not be a too much issue because it's a very small packet. You can keep resending it. So 1 megahertz and 2 megahertz gives you exceptional long range, like 1 kilometer plus kind of range. But if you want to have a video call or something like that, you may want to use 4 megahertz or 8 megahertz, 16 if you are in select countries. But you get the point. Basically, the fatter the pipe, the more bandwidth you get. The smaller the pipe, the more range you get. So this is what we are talking about. Wi-Fi HaLOW, sub-gigahertz band. So what about other technologies? You must have, if you are talking about IoT devices, you must have heard of LoRaWAN, you must have heard of Zigbee, Sigfox, Bluetooth low energy, Winsun, narrow band IoT devices, all those things, all this technology exists. Now the benefit of this puppy is that high speed and bandwidth both are available with range. Meaning if you have a logarithmic distance in terms of bandwidth, and logarithmic distance in terms of distance, you'll find, hey, Bluetooth goes very far. No, it only goes to 100 meters. It's very low. If you want Bluetooth to work for kilometer, forget about it. Same with Zigbee. Again, Zigbee uses 2.5 gigahertz. Many devices of them actually use 2.5 gigahertz. Like, why? Well, 2.5 gigahertz unlicensed band. You can go YOLO on it. So almost everybody builds it. But it does come with a penalty that it does not, like frequency itself does not travel far. So this Wi-Fi HaLOW travels very far, as in more than 1 kilometer. And yes, people have used it, do use it on a regular basis beyond 1 kilometer. Of course, not the maximum fattest pipe possible, but more of like, we have a contact, we have a sensor, it's just like, collecting data wirelessly 1 kilometer away. Heck, it could be even be a time-lapse camera, which you could just like send you one packet 1 hour wise. So it's basically high speed, high bandwidth for this ecosystem, for IoT devices, for low energy devices, for long range devices. If you compare it to normal Wi-Fi, it's going to be look laughably slow. But compare it to something that can talk to anything that, let's say 100 meter away, anything 200 meter away, it's like, yeah, this is the only king in town with high enough pipe. Like, you can use other things to communicate, but it's just like data bandwidth would be very low. And it's just as easy as Wi-Fi. This is a very critical thing. For example, what if you want to design a tool that allows to use Wi-Fi HaLOW as a backbone, and then you want to travel around. Let's say you have a property, you set a Wi-Fi transmitter, Wi-Fi HaLOW transmitter, and you want to have a receiver on your backpack and you're just moving around. Or in your tractor is moving in the field and you want to collect all the sensor data and all that jazz. You can buy something like this, Wi-Fi HaLOW portable gateway. It's a simple thing. Why it's a simple thing? Well, it's Wi-Fi. Of course, the radio is different. Of course, basically it does have a different tool set, but core is the same. So porting data from one Wi-Fi network to another is child's play. So that's another advantage. And good security and over-the-air firmware availability. That is a very desirable thing. For example, recently you must have paid attention to the fact that we have a lot of news where we are talking about, hey, we are getting a lot of bot attacks, we are getting a lot of denial of service attack. Where they are coming from? Are they coming from PC? No, PC have really good security. Not amazing, but it does have some layer. Smartphones gets a lot of scrutiny and a lot of some effort is put into their security. Which is the least secure and unnecessarily powerful device? Your smart appliances. Their power is, like in terms of compute power, is very high. Why? They're using ARM cores. So they are powerful in terms of compute. In terms of security, yeah, lol. What is security? And especially if they are using one of these custom frequency, fundamentally those things are not very secured. They are not designed to be. They do not have the rigorous structure of a Wi-Fi network. Again, Wi-Fi network itself is not that very secure. Then imagine how weak other things would be. Other things are like, lol. Oh, you think it's encryption? It's like, it's lol. You want something that has some probability of withstanding. And that's why you generally do not hear about like, oh, we had denial of service attack because all smartphones were compromised. You unlikely to hear something like that. It's not impossible, let that be very clear, but it's just like the probability of attack of that magnitude is very hard to do. Not impossible, hard, because there are way too many security agents working their ass off to make sure that does not happen. Smart devices, lol. So good security, and on top of that, let's say you find a vulnerability. The core protocol is Wi-Fi 5. It was designed in that way where it's like, hey, what if we find a backdoor? What if we find a issue? How do we patch it? Over the air system is inbuilt into it. You do not have to redesign the system or go to the hardware. Like if you had Zigbee or LoRaWAN, you have to go to the physical device and then you have to reset them and then you have to flash firmware on them. Again, not an issue. Very large number of devices. This is the bonkers part of it. Because which I do find odd, given the fact that people are showing Zigbee and LoRa devices as a, like, I'm gonna connect all the house switches and all. I'm like, your house could have like a lot of devices, like lot of devices, especially if every switch is connected. How the heck you are connecting it? Like, is it limited to 128 or whatever have you? Like, you may require 2 hotspots to manage it. So this Wi-Fi HaLOW is specifically designed to combat that. 1000 plus devices, and each device would be maintaining a connection. Of course, not each device is transmitting like full HD video, but you get the point. Like 1000 connected devices. Imagine you are monitoring a complex situation. Like, let's say you are monitoring a dam. There are many places where you want to collect pressure data, many places temperature data and all that jazz. You can do that. This device will be like, I got this. I can manage all the throughput. Relay node topology is also built into it. This is another aspect. The idea is that you can have a Wi-Fi router, another Wi-Fi router, another Wi-Fi router, or like the nodes, basically nodes like this, and data packets can jump from A to B. Meaning, rather than going from start to end directly, it will go the nearest one and then keep hopping it. Other systems also use that, and that allows you to have very long distance. Meaning, let's say you are covering a query and you have a lot of sensors and data gathering instrument, but each device itself cannot be very long distance. But you can put, hey, you can, let's say maximum screen range is 1 kilometer. Okay, I'm gonna put something 800 meters away, something else 800 meters. Now you can hop as far as you want and you can have very large coverage. So relay node topology is designed for vast setup if you really want to go all out, and you do have large number of device possible. So you can go like some people are saying, like smart city level things can be done with this. And very low power draw for battery applications, meaning you can even have something that is running on coin cell. The fundamental principles have been designed in such a way that it can go down very low power draw. And only one device that actually has this sort of range with HD video capability, meaning you can have a security camera that is running on a lithium ion cell and it will like, I got this. Heck, if you are putting it like, let's say, a large installation, it's cheaper for them to just have a solar panel, a small solar panel on them, and some primary cells as a failover. So solar is most of the time, if let's say cloudy rain happens, then you drain the primary cell. So these sort of things are only possible in this system, meaning you're not gonna buy a Zigbee hotspot which is like, hey, I'm gonna do the data backhaul. Yeah, that's not happening. So, and long penetration. Many other systems only use 2.5 gigahertz because of the licensing issue, but 2.5 gigahertz is 2.5 gigahertz. Your microwave screams at that spectrum, so it's a very noisy environment. And the penetration power of 2.5 gigahertz fundamentally lower than 1 sub gigahertz. So that's why there is some significant advantage with these puppies. So what were the tools? Now, tools wise, there are only a few companies that is actually making the actual silicon. Morse Micro, Texin Semiconductor, and NeuRacom. NeuRacom is making some really good tools, and they really have very good YouTube channel where you can see them demonstrating the abilities. They do showcase a lot of abilities, and Morse Micro also has some good YouTube presence where you can see what they are talking about, like how we are developing things. I have linked some videos down below. Texin, good luck with that. They rarely have any presence. So they are the companies that are actually going to, let's say, Wi-Fi association. It's like, okay, what we have to do. They are sorting the algorithm parts out. They are developing the core tech, and then they are making the silicon on basically system on a chip or module maker. Because nowadays it's kind of easy for mid-range manufacturers. Basically, if you are only planning to make, let's say, 500 of them, it's unwise to try to build the whole PCB. It's like, hey, just build a PCB that accepts the modules like this, and then just put whatever else you need to put on it. So it simplifies development cost exponentially. So that's a way of doing it. And there are other brands that take these modules, quote unquote, or modules or silicon, and then they develop the final product that you and I is gonna buy, basically. And they make a lot of cameras, cell effects, they make a lot of Wi-Fi repeaters, hotspot, Ethernet backend, and alpha These brands are the one making it. Now, they make products for almost everything from consumer end to commercial market. However, unfortunately, in India, the availability is lol. It's like it's just not there. Availability is not there. It's very difficult to find these sort of things in Amazon also. Even in abroad, if you have access to Alibaba, it's not an issue. But anything else, you may find frustratingly difficult to get it. These things more likely appear that they are used in large installation. So like people who know they need this, they already have it. It's not for, they have a public use, but it's not very popular. Not yet. So what about use cases? Now, use cases, you have to understand if you are jumping into this ecosystem, do you actually need that unique offering? For example, like this module, like, do you need that unique advantage? It has that 900 megahertz advantage. The fact that it can support very high client density. Do you need those sort of things? It has having internet on the device itself. Basically, you have a camera and you want internet gateway directly to this point. Not like, okay, I have a hub, that hub is like, acting as a back door for it. No, this device itself be able to use internet. Again, that's up to you. Do you need that? If it's desirable or not, that's up to you. And don't expect it to show up in your mobile phone or router anytime soon. Wi-Fi 7 is going to happen and all those jazz will happen, but likelihood of manufacture, like let's say Apple or Samsung going like, you know what, we're going to install Wi-Fi HaLOW in our smartphone. While it will have amazing use, heck, imagine this way, if Samsung is like, hey, you know what, we're going to give Wi-Fi HaLOW, and they have like, that mesh network topology. If your nearest Samsung smartphone is like, let's say 300 meters away, you can have an internet packet network where you can just like transfer small packets globally, just hopping from one mobile phone to another mobile phone. Latency would be low, and some companies did try to make this sort of torrent network of mobile interface, but it can be done in principle, but I do not expect it to actually become a thing. So mobile or home router, I do not expect them to use this sort of chips anytime soon. Security cameras are really desirable, especially if you need security camera at hundreds of meter far away. You will find very quickly, and you're like, what if I have 2.5 gigahertz and this giant antenna and focus it there? Yeah, you can do that. It does work. It's a real thing. It's just the issue is not only the cost is also high, the power draw is very brutal. So if it's battery powered and all that, you may be like, it may be cheaper, like just lay down a fiber there. So there are certain scenarios where only this technology will work. Most IoT sensors can use them very easily without any issue, but offerings are slim. At this point in time, like I'm seeing companies saying, hey, this is the module. I'm like, dude, give me the product. I'm not going to buy the module, build a PCB, then put it. So I'm seeing a lot of what you will call back-end development. I'm not saying front-end yet. So this was my presentation on Wi-Fi HaLOW. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.